So hello everyone, we are back again with our new video on SQL tutorial Ebicacho by Ebicacho groups. So basically this video is going to cover normalization in SQL Server. Now let's move on and check what are normalizations in SQL Server. Okay, so data normalization in SQL Server. Data normalization in SQL Server is a process used to organize data in a database efficiently. It involves structuring a database in accordance with a series of normal forms to reduce redundancy and improve data integrity. So what are the problems caused if our data is redundant? Okay, so problems of data redundancy. So disk space wastage, data inconsistency, DML queries will be slow, like insert, update and delete will perform slow if our data is redundant. Okay, now why normalization? So basically normalization eliminates redundancy, avoid storing duplicate data, and it improves data integrity, that it ensures consistency and accuracy of data, and it optimizes storage, save space by organizing data in logical form. Okay, so benefits of normalization are like consistency, avoids anomalies during data insertion, deletion or updates. Okay, efficiency, reduces storage requirements, scalability, makes the data easier to maintain and expand. Okay, now move on. So normal form. So normalization is achieved through various stages that are called the normal forms, and below are the normal forms that we required for normalizing our data. So these are like first normal form, which is also called 1NF, second normal form 2NF, third normal form 3NF, Boas code normal form BCNF, and the fourth normal form, which is 4NF. Okay, now move on and discuss each of them one by one. So what is the first normal form? 1NF. So for a table to be in first normal form, it should follow the following four rules. So it should only have single atomic valued attributes or columns. Okay. Second, the value stored in a column should be of the same domain. Okay. Now all the columns in a table should have unique names. And last one is, and the order in which data is stored should not matter. So order in the table is not going to matter for 1NF. So basically we have an example for 1NF. This table is unnormalized. So basically you can see here there are all the columns with different attributes, but in employee column we have the data which is not having single data. It is comma separated data, and other than that the domain is also matching for all of the column. So how we are going to normalize this particular table? Now let's move on to next slide and check. So basically for normalizing to 1NF, what we have done, so we have separated that employee skill with employee ID and employee skill. We have created one more table where the employee skill are separated each in each row. Okay, and here we have the employee ID, employee name and employee mobile number. So by using this particular format we can normalize our data by distributing it into two tables. Okay, now move on to the next one. So next we have the 2NF or second normal form. So for a table to be in second normal form, it should be in the first normal form. Okay, and it should have not partial dependency. Okay, it should not have partial dependency. So what is partial dependency? So basically if we have a composite primary key, so composite primary key refers to if more than one table is available in primary key, means if the primary key is created by combining two tables, then that particular situation is called the composite primary key. So here you can see student ID and subject ID together making a primary key. So partial dependency is when a column is not directly dependent to the whole primary key. So here you can see we have student ID, subject ID, marks and the teacher name. So teacher name is directly proportional, directly dependent to subject ID, but it is not directly dependent to student ID. So there is a partial dependency on the primary key. So now to resolve this particular dependency, how we have done? So for making second normal form, what we have done, we have distributed it into two tables where we have in one table we have the subject ID, subject name and the teacher's name, and then in the next table we have the student ID, subject ID and the marks, because mark is dependent directly to both of the primary keys, as you can see. So now move on to the third normal form or 3NF. So our table is said to be in third normal form when it satisfies the first normal form and the second normal form, and it does not have transitive dependency. So what is transitive dependency? So transitive dependency is the case where two columns are not primary key, but one column is dependent on the other column, but both are not primary key. Okay, so here you can see in this particular table we have student id, subject id, marks, exam type, and total marks. So here total marks is dependent on exam id, exam type, but exam type and total marks, in both of them, no one is the primary key. We have the primary key as student id and subject id. So this particular condition is called the transitive dependency, and it is making the data redundant. So taking this particular data in third normal form, what we have done, we have created a separate table like exam type id, and then exam type, then total marks and duration. We have removed this the two columns like exam type and total marks, and we have created a separate table for that, where we have taken exam type id, exam type, and total marks and duration also. Okay, so now move on to the next normal form. So next we have the Boyes code normal form, or BCNF. Okay, so Boyes code normal form is a higher version of the third normal form. So this form deals with a certain type of anomaly that is not handled by 3NF. So a 3NF table that does not have multiple overlapping candidate keys is said to be in BCNF. Okay, so multiple overlapping candidate key. So candidate key is what? So candidate keys are those keys, means those columns which have unique values in their rows. Okay, so they have the capability to become the primary key, but they are not the primary key, but they maintain the uniqueness in their data. Okay, so those columns are called the candidate keys. So for a table to be in BCNF, the following condition must be satisfied. So table must be in third normal form, and for each functional dependency x dependent to y, x should be a super key. So now move on to the example what we have. So here in the example you can see we have a table where student id, subject, and then instructor we have. So you can see instructor is means subject is dependent on instructor, but instructor is not a primary key here. Okay, so basically for doing it into BCNF form, means Boyes code normal form, we have distributed into two tables like instructor subject and student instructor. So in instructor subject we have the instructor with the subject. So here the instructor is the primary key, and then we have the student id, and then the structure, then the instructor. Okay, so now BCNF is clear. Now move on to the next one. So next we have the 4NF, fourth normal form. So 4NF deal with multi-valued dependency. A multi-valued dependency occurs when one attribute in a table uniquely determines another attribute, but they are not directly related to each other. Okay, so one table is uniquely determining the other table, but both are not related to each other. So a table is said to be in the fourth normal form when it is in the Boyes code normal form and it does not have multi-valued dependency. So move on to the example. So here we have an example like student hobby. So here you can see student ID, hobby, and language. And here hobby and language are not means related to each other in any way. Both are unique, but both are dependent to the student ID. So these are making multi-valued redundancy. Okay, so for resolving this and making it into fourth normal form, what we have done, we can distribute it into two tables like student hobby and student language. So student hobby will have student id and the hobby, and the student language have student id and the language. Okay, so all the normalization has been cleared here, and these are very important for the perspective of interviews also, and when you are going to do jobs, in that jobs also you need to sometime normalize your data, as when the data is pulled from the data warehouses, they are not in not they are not expected to be in normal form, and these normalization techniques are mostly used in